it doesn't really make a difference. So the first thing that I'm going to do is we're going to talk about Python, right? So first of all, I just want to check what folder that I'm in. And you can see here that I'm in the C users ACATS class ISAN 5357 folder. This is important to know where your folder is, because when you're importing files, you can easily import files from the folder that you're directly in. So first thing I'm going to do is I'm going to type in import pandas as PD. You can put whatever you want in there, but for me, I put import pandas as PD. The acronym is helpful, basically. It's actually good for working with pandas, so I would say acronym is needed
Yes.
in a sense, since you are dealing
Once you open
with the
the last email,
package
there's a
a
link there.
lot. Now,
Yes, there's a link.
the
I'll
next
click
thing,
on
okay,
it
first of all, I need to run this. The
and
next thing
who
I
is
want to
teaching.
do is I want to
The last
read
link
my
in
file.
the mail.
So let
The mail there's
me
a
let me click on this file. Let me show you
yes.
what. Okay, this is my file. All right. I have a customer ID, a sales total, a number of orders, and agenda.
Okay.
All right. So these are basically the file that I'm looking for.
Your network is
I'm going to import it by saying,
your network is not good.
call it whatever you want. I'm going to call it y sales for yearly sales is equal to pd.read underscore CSV. All right, and in here I can use this entire thing, copy, paste that, put that over here. All right, and then do slash yearly underscore sales dot CSV. Let me just make sure I have the name of it correctly. So it is yearly underscore sales dash one. So for me, it's dash one. Make sure
There is one way.
you name it however you put it correctly, dot CSV. In which case I can run this. All right, and I can do print y underscore sales. And you can see here that it shows me my customer ID, my sales total, my number of orders, and my gender. All right. Now, the thing about it is that it happened to do it correctly, 1,000 rows by 4 columns. It happened to do it really good and correctly. But this is not always going to happen. So sometimes what we should do is we should actually put an argument. Let me call this y underscore sales or SLS instead, so that I differentiate the two files. And pd.read underscore CSV, open parentheses, in which case, here's the thing. Because I'm in this folder, I don't need all of this. All right, all I can do is I can just call out the name of the file because I'm already in this folder over here. So I was showing you this if you need to retrieve from a different folder. But if it happens to be in the same folder, if from same folder, all you need to do is just call upon the dataset yearly underscore sales dash one dot CSV. That's the name of it for me. Secondly, I should put an argument which is separator equal, and I should put inside of here this comma. Why? Because it's a comma separated values file, in which means that every row is separated by a comma. That helps with making sure that it actually does get imported properly. Now, in this case, it did get imported properly, but I'm just saying sometimes it may not get imported properly, and that's why it is we would need this. So here I can do print y underscore SLS, all right, and we can see clearly it does the same thing as above, all right, but we made sure of it by using the separator function argument. You all with me on this so far? Any questions so far? Okay. I'm going to guess that you all are okay with it. Now, I can also use another argument to view the top of the file, I can use, the top of the data set. I can use a argument print head, open and close parentheses. Sorry, it's y underscore SLS dot head. And here you can see that it gives me the first 1, 2, 3, 4, 5 rows. Now I can do that. I can customize the same exact thing, right? And instead I can actually put, let's say, maybe the first 10 rows that I want, in which case you can see that it gives me this. I can also do similar to it to see the end of the data set by doing something very similar. Instead, however, I just do tails, or actually tail. And here you can see it gives me the last 5 rows. And obviously, if I wanted, let's say, 15 rows instead, you would see that it gives me 15 rows instead. All right. So this is how you can more or less, just view your data set. Something which you should actually do quite often whenever it is that you're actually running any type of data analytics or inspecting any data set and whatnot. Now, I can also skip the print function, and I can just do y underscore SLS. All right, and you can see that it actually produces it, where it shows you the first 5 rows and the last 5 rows. It shows you all the columns. It looks like a nice table in a sense, but you can't really do much more than it. And one of the reasons why this is not really good is because if we did both of these, all right, you'll see that it only takes one of them, in which case it's actually taking the second one. So that's why it is that we should use the print function if we want to display more than one table in a Jupyter cell. You with me on this so far? Okay. There are a couple of other things that we can do. We can do print, and we can look at the type of y underscore SLS. All right, in which case you can see that it's a Panda data frame. All right, so it's a Pandas data frame. This is what it's stored as. You can also do print shape. So print the shape y underscore SLS dot shape, in which case that it will tell you what the structure of it is. So it's telling you that it has 1,000 rows and 4 columns. Tells us how much rows and columns exist in this data set. And then we can also do print the columns. So y underscore SLS, or rather I should do a print y underscore SLS dot columns. So now let's say I want to see the column names. I can see, okay, well, the column names are customer ID, sales total, number of orders, gender, and it's all stored as a object. Why do I want to know this? Because sometimes I'll have to use these names when it is that I want to filter data. So this here is just basically, let me add this and go up one. This here is just basically markdown. Importing data. All right, now the next thing I want to do is go all the way to the bottom here. The next thing I want to do is check the data types. In which case, there are four data types that we will be concerned with. The columns in the data frame using the .d types open or .info open and close parentheses depending on how much information you desire. The common data types are, and we have object, a common data type similar to a string in regular Python. We also have a int 64, which is the whole numbers similar to integer in regular Python. We have the float 64, which is decimal numbers similar to integer in regular Python. And then lastly, we also have the date time 64, which is variable that describes dates or times, or basically both. So we can check data types by doing this. Let me put this in a different color actually. So font color equals, maybe I should put it in sea green, and I should be able to do a /f here. Yep, that works. Okay, so now the next thing we want to do.
Number 3, I think is float equal to decimal number to float. Is it integer?
Oh yeah.
Number
Float. My bad. Thank you. All right. Now the next thing we want to do is we want to look at our d types. So we can do print y underscore sls dot d types. All right, and this will indicate the data types per column and variable. It's the data type for each column or the variable that we're looking at. In which case you can see here that it's telling us customer ID is integer 64, sales total is a float 64, number of orders is integer 64, and gender is object. We can also decide if we wanted to, we can do a print, and we can do y underscore for more comprehensive information, or more information, including the null values per variable. We can do a print, and in this case we just do a .info. So y underscore sls .info open and close parentheses. So now here you can see customer ID non-null, meaning how many nulls does it have? This actually indicates to us if it is that we have a full data set or not. It's telling us that all of our 10,000 records are not null, so that's why we have non-null count. 10,000 not null, 10,000 not null, 10,000 not null. And then the data types which correspond to what we're seeing over here, right? You can also see some memory usage in here if it is that you'd like. but generally speaking, this is what the .info would do. Now, the .info, in my opinion, is a much better, it's a much better function to use. And the reason why you should use this function more to do data analytics is because you would have to check for things like how many null values you have and the data types themselves as well. All right, everyone with me on this so far? We can also isolate, simply put, a single variable. So to isolate a single variable, all we can do, or what we can do, is print y underscore SLS dot d types and open and close parentheses, square brackets, and inside of here we'll do sales underscore total. And here we can see that it's a float 64. We can also do the same thing for any particular variables as well. Now, one other thing that we can do, which is really helpful, is we can get some summary statistics, which is, again, something you would need in data analytics. So summary statistics. And here we can just do print, open and close parentheses, y underscore sales, or SLS actually, dot describe, which will do that for us. And here you can see that it is going to give us certain things. It's going to tell us the count, the mean, the standard deviation, the minimum, 25, 50, and 75 percentiles, and the maximum. But it only does that with numerical data. Does this with only numerical, which means either integer or float, data types. Notice the gender is missing, right? And that's because it cannot describe the count, the mean, the standard deviation of a categorical variable. And this is a categorical variable. Gender here is categorical. When we look into analytics, and your analytics classes and your others, stats classes should tell you this, there are two types of variables, right? So there are two types of variables. You have the continuous or numeric variables, which are values that can take, or actually each row or each data point can take any value within a specified range. So for instance, it can be, for instance, you can have 8.234 in the range of 0 to 100. Or you can also have minus 10 in the range of negative infinity to positive infinity. Right? That's the first one. The second one is a categorical variable, in which case a data point or a row of that particular variable can only take a value that is already specified. Example, hot or cold, or even numbers that have meaning, like 1 for yes and 0 for no. So this is categorical, and this is important for us to know. So here we can only calculate these things with the numeric variables, with the continuous or numerical variables. If we want to be able to do it for the categorical variables, we can actually do that by saying print y underscore SLS dot describe, and we can have the include function inside of here, include equals object. All right, so to get only the object data types or the categorical variables. And here you can see, instead of it having a count and a mean and everything like that, here you can see that it has only the categorical variable, which is given to us with values of count, unique, so how many unique values we have? 2. The top is female with a frequency of 50, 35, which means that out of this 10,000, 50, 35 is female, and the remaining 4,965 would actually be males. All right, so this is if you have two categories inside of there. Now we can also do one other thing, which is print open parentheses y underscore sales dot describe, and we can actually do include equals all. And now if we do this, includes every single variable, but it looks very ugly. So here you can see that it has a count, the unique, the top, the frequency. These do not count. We do not get values for this in the customer ID, the sales total, or the number of orders, but we do get it for the gender. And likewise, we get the mean, standard deviation, minimum, maximum, and the percentiles for all the numerics, but then for gender, we don't actually get anything. So this is generally how you would do some quick descriptions. If you have more than 2 categories, there are different ways to test that, but I'm not going to concentrate on that one right at this moment. With me on this so far? So the next thing that we want to do is how to create a data frame in Pandas. So font color equals sea green and /i/f. And inside of here, I'm going to put in my text, create data frames with Pandas. Now, let's see how we do this. Let's say we have three lists. So here we have 1, 2. I'm just going to put any values inside of here. All right, 2, 10, 14, 84, and let's say 90 is our last one. So how many I have here? 1, 2, 3, 4, 5, 6. All right, so I need to have 6 values in here. Scores equal actually, let me change this up a little bit. 1, 2, 1. Let me do this. 3, 2, 1, 2. There's a reason why I wanted to do it like this. 2, 1, 2, and then 1. So I have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I do have 8. And inside of here, I'm just going to put numbers. So let's do 9, 76. Let's do, I guess, whatever numbers you want to put in there. You can make it random as possible. 52, 72, 89, 70, and let's do 100. And that should also be 1, 2, 3, 4, 5, 6, 7, 8. And then let's do price, in which case we'll do yes, 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 no for whatever reason. This doesn't have to make sense right now. It's just basically to show you something. Yes, throughout. One, two, three, 4, 5, 6, 7, 8. So now I can do df1 is equal to, that's what I want to call it. You can call it whatever you want. pd.data frame, open parentheses. And in here, I'll do this squiggly brackets. And I can do ranks, because that's what I want to call it. And I'll do a colon. And I'll just call upon the list that I want. Now, put a comma. All right, I can do scores and put a colon and just do scores after that. That's what I called it. All right, and then I can do price, but I want to actually change it up just so that I can show you price acquired, just to show you how it is that what you're calling upon versus what it is that you're actually doing. So here I have price acquired, and this is price. So now you can see that these that I'm putting, these that are in red, these are all the names of the variables in this data frame. And the values of these variables are just being taken from the lists that I have here. So you can see we can name them the exact same, or we can change up the names as we want. And now I'll do a print df1, and you can see clearly ranks, scores, price acquired. Go with me on this so far? We can do a print df1.info, open and close parentheses. All right, and you can see that ranks, scores, and price acquired, 888, all of them are non-null. We have ranks as an object, scores as an integer, and price acquired as an object. And why do we have these as objects and integers? Because when we were inputting this data, these we just put without the comma, without the quotations, all right? And this made it integers for us. Whereas these numbers we put in quotations, and that made it an object, or basically like a string for us. We can also see, it can also describe, we can also describe stuff. So I can do print df1.describe, and I want to describe everything. So I'll do include equals all. Actually, no, I just want to do this. So here we can see scores is the only one, because that was the only integer that we had. All right, and you can see the count, the mean, and all of these statistics in general. So we have 70 happening to be the mean, 28.9, 7 happens to be the standard deviation with a minimum 9 and a maximum 100. And we can also see the quartiles inside of there as well. Now we can also do a print df1.describe, open and close parentheses, and we can do an include equals, and from here I'm going to just want to include just the object type. So now you can see that when I put object, just like I did it over here, when I include object, you can see that it's putting ranks and it's putting the price acquired for us. This has three values to it, but we only see the top one, which is the top frequency. Frequency is 1, which appeared 4 times, and this has 2, in which case we have yes, which appeared 7 times because we only had 1 no inside of here. Now, this is also very similar to the creation of a dictionary. Or let's say we created a dictionary, All right, this is just regular Python coding. So let's call this data is equal to, and let's put some squiggly lines here. In which case, for a dictionary, you can just put name. You can put a colon, and inside square brackets, you can put your data inside of there. So this is like how you would. It's like a dictionary is kind of like having the variable name and then the list itself. So we can do Adam, Mary, and let's say Joanne. Sorry if I'm yawning a lot. That's just the anesthesia just kind of working on my system a little bit. So sorry about that. Johan, right? Then after that, I want to put another one, which I can put right here on this line, age, and I can just do 42. Now I do want to match them, obviously, so that's why I'm putting 42, 44, and 15. Now I can keep it in this line or I can go down one, it really doesn't matter. Here I can create a data frame out of this, but let me print this first, print data. All right, let me print open and close parentheses, and then let me do df2 is equal to pd.dataframe, open parentheses, data1. So now this will make things a lot easier for us. And because we already have these names over here, right? In a dictionary, we already have these names. So now I can just do print df2, and I can also do another little small print over here and print df2.info, open and close parentheses. So now this should produce a nice report for us, in which case, I don't know why I keep putting data one. That's because I don't really name anything data by itself. All right, so here you can see this is the dictionary that we have, name, age. It looks just like a regular table, all right? But we also want to make it into a pandas object, which we did over here. Oh wait, sorry, my bad. Here's the data. This is the dictionary, so it just prints it out like this, right? Which is fine, I guess, but if you have a lot of data, it doesn't work well. So putting it as a data frame or a table is what we really want. So this is our data frame over here, and then this is our this is the description of our data frame, in which case we see that we have one object and one integer. We can also index these rows as well. So we can give rows names as well using the index argument. So let's do df3 just want to check something. It says df1 df1. Just want to make sure I have all my dfs properly. Okay, so let's call this df3 is equal to pd.dataframe. Data is equal to, and here we can do age, and there's a reason why I want to redo this now. So I want to show you how you can input data while creating a data frame. So rather than, okay, if we look at this one that we did at the top, right? We already created 3 lists and just compiled them. In this one over here, we didn't have to create a list because the dictionary already handled the structuring for us, so we just call upon the dataset in and of itself. And this is important because sometimes you will get certain how to put it, certain data sets that you would need to change into a data frame in order to do analytics properly. All right, and then finally, we can also just put the data right in here, in which case I can do 23, 44, and then 21. Put a comma over here, go down to rule. Now this is not the best looking one, obviously, but it works. Admin. Let's do audit. And let's also do another admin once more. And then finally, let's do the last one, which is salary. And in here, we'll just do 98,000, 100,000, and let's say this one is 95,500. All right. Now, if I were to run this, print df3, if I were to do that, you would see that, okay, well, age, role, and salary, but we don't know who these are, right? So let me edit this code once more, and let me put a comma after the squiggly bracket. I'm going back to this top over here, in which case I can get the argument index, and then do, let's say, Mary, Sam, right? Now, if I print that, you can see that the rows themselves now have names the same way that these columns have names. And then finally, I can just do something like this if I'd like. I can do a print, and I can do an F, and I can do the mean age is, and I can do a round, open parentheses, df3, open and close brackets, and let's say there's a particular column that I want to get the mean from. I can just do age. All right, that's one column that we have, or rather, let me do salary. Well, actually, no, I'm doing age already. The mean age is, and then from here, I can do dot mean, open and close parentheses. All right, comma 2, and the comma 2 is based on the round that we have here. This that we have here, simply put, this is the command that we would do just to calculate the mean age. And then I run this, and you can see that the mean age is 29.33. You with me on this so far? Okay. If you have any questions, let me know. All right, now let me go to another markdown, and let me do subsetting of data. Now, subsetting of data, we kind of just showed that a little bit earlier by doing this over here. Instead of me doing the entire thing, like I could have just done, like it could have calculated the mean for multiple of them. Instead of it doing that, it just calculated it for one variable, and that is basically what subsetting of data is. So let's say we wanted to get a specific column. So here I have print, and let's do y underscore c SLS, and let's do sales underscore total. Right here, we can see that it's just going to print out. It's just going to print out only the sales total column for us. Now, what do I do if I want multiple columns? For multiple columns, I'll do print and same square bracket. Actually, sorry, this and the y underscore SLS and the same square bracket after that. In which case, I'm going to do, if I just had one variable, I just keep one sales bracket. Now, if I have more than one, and just more than one, it doesn't mean that I have to put a bracket per variable. No, if I just have more than one variable, because this is a 2 by 2 dimension, I have two square brackets, in which case I'll do sales total underscore total, and let's do also the gender. right? And here you can see that it prints it out for me exactly like that. Let's do one more. This is exactly the same thing that we had here. So I'm just going to copy and paste this. I don't need a print statement here if I don't want to. That's completely fine. And instead of gender, let's keep gender, but let's also do the customer ID. So I do not remember cost underscore ID. So cost underscore ID. All right, and you can see that in this case, it is producing the sales total for us, the gender, and the customer ID with only 2 square brackets. All right. The other thing that I would like to make mention of is look at how it changed the order of things. I put sales total as first when customer ID was originally first. So it changed the order of it for me by basically presenting the customer ID afterwards. How we present it inside of here is how it would appear for us in our tables itself. We can also save onto a different list if we want. So I can create a list and save data from the data frame into it. And the way to do that is very simple. Let's say I call this sales T, for instance. Sales T is equal to Y underscore SLS, and inside of here, sales underscore total. So now I can print sales T, in which case it just basically it's its own thing for me. And I might want to do I might want to know what type I might want to know what is its overall structure, or what do I call it? What it is in a sense. So with that, I can just basically do the shape of it or the type of it. So I can do print the type of SALST. All right, in which case it's telling me that's what is called a pandas series. Now a series is just basically this, just one variable in a sense. All right, if I were to do this instead, so let's say create a pandas table from the main table, I can do, let's say, sales G, for instance, for gender, and I can do the same thing that I have over here, right? Y sales, Y underscore SLS, open and close square brackets, and I can do inside of here the sales underscore totals, which should be common letters, sales underscore total. All right, and then I can also do gender. But I do have an error. So how about if I put this here, right? Now it should work, and then I can also do print sales underscore G, print, open and close parentheses, print a type of sales underscore G. So we can see that it gives us this table for us, and it's also a data frame. So if it's just one single set of values, one single list of values in a sense, it's called a series. So a series is kind of like just a list. Whereas a data frame is multidimensional. Now, obviously, we already, let me see what else I need to talk about with regards to this. So this is us subsetting data and creating new files. All right. We can also do the same thing with regards to indexing rows. So let me go down a bit, and we make this into a markdown and say indexing rows. So we see how to index columns, and that's just by calling out the column names, right? So how do we do that with rows itself? Well, the first thing that we can do is we just basically use a number, but we use a function known as loc. So we can do print and let's do y underscore SLS dot head, open and close parentheses, right? Now let's do another print, open and close parentheses, and let's do let me actually do two prints here. So that'll give us enough space. Now let's do this. Let's do a print y underscore SLS dot loc, open and close parentheses, and let's say we wanted the fourth, row. So if we look at it, or actually we want the row that is labeled 4, not the loc is for the label of the row, the index of the row. This is not the fourth row, because the fourth row would actually be this, all right? However, we're asking for the row that is labeled 4, in which case, remember, Python starts with 0, right? So in this case, we have this value that is being printed for us. The loc is for the name of the row. Now, if we wanted to get the number, like let's say we wanted to get the fourth row, then I can do print y underscore SLS dot iloc, and then I can do 4 inside of here, in which case you can see that it is that is actually supposed to give me iloc is actually supposed to give me okay, never mind. I don't know why iloc is doing that, but anyways, we could also, this is actually supposed to give me oh wait, now I know why it's doing that. Because when we want to use it, when we're using these, if the row names are the index as is, then it doesn't matter which one we use. But if it is that we named the rows differently, like for instance, how where is it? How we have this one over here, the iloc and the loc actually matter. So let me do this with df3 instead. So let me do print df3 dot loc, and let's say we wanted number 2. So now we have an error, but let me change this to iloc, and you can see that it is number 2 is Dean, salary which is 95,500, role admin, age 21. The iloc is actually allowing us to use the index based on the number. But if we wanted to print df3 dot loc, all right, remember when I use loc 2, it's not going to work. But if let's say I put inside of here Mary, now you can see that it's actually pulling up Mary for me. Likewise, if I were to do a print, open and close parentheses, and another print df3 dot loc, and let's say Dean, all right, you'll see that it's pulling up these information for me. So the loc and the iloc actually matters when it is that we have row names. So let me put a note here. Without row names, it will not matter much, because it's always going to start from 0. So the iloc, as we see, can clearly, if we look at the iloc is with the index number, no matter what. Whereas loc, the location for, well, the loc is for the name of the row. All right. So in this case, it didn't actually matter because the name of the row, when we use this for over here, that was the name of the row. And likewise, when we use this for over here, it is still going to count from 0, 1, 2, 3, 4. That's why it didn't actually matter whatsoever. Now we can also go backwards if we would like, in which case you would have to use an iloc. But not entirely sure why you would probably want. Well, yeah, you might actually want to do that. So you can do y_sls.iloc and -1 in this case, and you can see that it's just basically -1. If I did -1, which means that it's going to this value over here. If I did -2, it would go upwards, but again, it's a very number of orders, mail, 100999. Oh, wait, sorry, I now realize why this is doing this. Is because it's going backwards in the entire data set itself. So we're not going to see this. Let me do a tails instead. Let me do print y_sls.tail. All right, and let me bring this downwards. So see, if I do -1, you'll see it says 10.999, right? Which is this one over here. And let me run this. So actually, sorry, if I do -1, it's going to show me the last row altogether, which is this 11,000. And if I did, let's say, -2, copy and paste this, -2, you would see that it would give me the row just above that. Now, what if we want to get both rows and columns at the same time? Before I go on, is everyone with me so far? Okay, I'm going to assume everyone's fine. So now, if I want to get both rows and columns, very simple process, print. Then here I can do y_sls dot lock. Now remember what lock does? Lock does the name of the row, but it also does it for the columns as well. So I can do 2, comma, and here I can do gender, and also without having to do like an extra bracket inside of there, I can do sales_total as well, right? And see, here it can show me the gender, which is male, and this is just for one record, gender, which is male. The sales total is 74.58, right? Now, if we go up to here, right, the sales total is 74.58 and the gender is male. So we can see that it's the name too, and it's these two variables that we're looking at. Similarly, I can actually get a number of rows if I wanted to, right? So I can do y_sls dot lock, and inside of the square brackets, now I'm going to do 2 to 23, all right? And then I'm also going to do gender and sales_total. So now, actually, instead of 2, let me do, let's say, 12. So now, if I look at it, I can actually identify some of this data set by just partitioning it, or not partitioning it, but subsetting it or filtering it using the lock function or lock argument. I can also get rows and columns that I specifically want. Like, for instance, I can do print y_sls dot lock, open square brackets, in which case I can do certain row numbers, in which case because it's row names, sorry, because it's a certain row names that I want, I can actually, I will have to actually put another square brackets in here, just like I do with columns. So let's say I want 2, 5, and 10. And then after that, I want, let's say, the sales underscore total. And let's say I also wanted the gender. All right. So notice I had to put a square bracket in here for these sales and total and gender, because these are the columns. And I had to put a square bracket for these rows that I want. So here, when I do that, you can see that it's giving me 2, 5, and 10. All right. And you can see that it's giving me the sales total and the gender as well. And likewise, we can also use iloc in this case, but it's not the most reliable because you kind of have to remember stuff. Well, maybe it might be reliable enough. It really depends. I can do a print y underscore SLS and dot iloc, in which case, let me just ignore, I don't want any rows in this case. I just only want columns. And remember, in iloc, we're doing the count, right? So we had 0, which was the customer ID, 1, which was the sales total, 2, which was the number of orders, and 3, which was the gender. So if I put 3 here, then you would see that it prints out the gender for me. So I can do, in this, I can say, the represents all rows. And likewise, I can do the same thing if I just wanted rows but no columns. Sorry, if I wanted a set of columns but just one row, because you cannot produce a column without a row. You can only produce the name of it, my bad. So here I can do y SLS underscore SLS dot iloc, and in this here, let's say I want 5 to, well, let me do 5 to 10, comma, and let's say I wanted 2 to 4. Now, why don't I need square brackets? Is because I'm not using names. I'm using numbers. That's why I'm using iloc in this case. So 5 to 10, meaning I want from 5, 6, 7, 8, and 9. Unfortunately, because whenever we do a range in Python, it always ignores the last number. That's just how Python works. And when I say 2 to 4, again, when you use a range in Python, it ignores the last one. So this customer ID was 0, 1 happened to be number of orders, and 2 happens to be gender, right? And 0 is customer ID. Wait, let me just do a quick print. So 0 is customer ID, sales total happens to be 2, number of orders happens to be 3, and gender happens to be 4. 0, 1, 2, 3, 0, 1, 2, 3, yes, actually, yes, okay, now I remember what I was trying to say. So 0 is customer ID, 1 is sales total, number of orders is 2, and gender is 3. If I had simply put 2 to 3 here, you would see only number of orders would have been produced because of the way ranges work in Python. But if I do 4, which doesn't exist, then it will give me the gender in this case. So that's how it is that Python, that's how it is we can filter in Pandas. So let me put a note here. The 5 to 10 is the 5 to 9 rows we want, and the 2 to 4 is for the third and fourth row. The 4 is non-existent, but is needed since 3 is the last column I'm sorry, this should be column, not row. All right, so that's why we need this. Now, you can
we try it with 1 to 3? I just want to see. It's a bit confusing. Yeah, just the 2 and 4 instead of 2 and 4. 1 to 3.
1 to 3. Here you would get sales total and number of orders. Why? Because 0 is customer ID, 1 is our sales total, which we're going to see produced over here. 2 happens to be our number of orders, and 3 is gender. But because of how ranges work, gender will not appear. Does that make sense?
Yeah, thank you.
Okay. So this is how we would basically use, if we're trying to index, we'll index using iloc and loc, right? And we can basically use these notation formats. Loc is for names. All right. Now, if your data set, if the rows doesn't have names, which is actually most of the times, then that's fine. You can basically just use loc, and the row, as you can see here, the row ranges are basically, the row numbers are its names. And if you do happen to have names, sorry, if you just want to use numbers in general, you can just use iloc in this case. Loc is for names, iloc is for numbers. You all with me on this so far? So what I want to look into now, or go into now, is the stats modules when it comes to using Pandas. Because again, Pandas is a statistical package, and more than statistical, it's for data analytics, which data analytics is stats. Earlier, we attained some summary statistics using the describe function, but we can do the same using other functions. And this is where I'm going to show you how it is that, let's say we wanted to calculate the mean, right? Calculate the mean, and I think we already did this. Print f the mean of sales total is, and we can put a $sign over there, put this curly brackets, put a round function inside of there if we want, y underscore SLS, in which case we can do sales it's sales underscore total, in which case after that we put a dot mean, and we can round it to, sorry, this dot mean needs parentheses, we can round it to 2 decimal places. All right, and we can print that as is, and I have a problem here.
You forgot the other, let's see, quotations.
Yeah, so now that works, right? Now, the other thing is, I can also just do, let's say we wanted to do like the means of the sales total per gender. We can do a group by function for this. So using group by. So group by is exactly what its name says. If we wanted to get the mean per groups, then we can do that by doing this. Print f, and I'll do round y underscore sales, or SLS actually, y underscore SLS dot group by, and I want to group it by the gender. And again, this is what you're going to be using in Python, in data analytics, especially when you're dealing with, let's say, large data sets and stuff like that. You can do, and also in dealing with visualizations, as we will come to in a couple of weeks. So here I can do sales underscore total, all right, dot mean, open and close parentheses, and because I want to round them all off to 2, because I want to round them all off to the nearest, because I want to just round them all off, I could just do this, 2. I actually do not know why I have that there. This makes more sense. So I just put a round function in there, sales, because I don't have a sentence that I want to put, round, y sales are group, gender, all right, then the mean, and I think actually I need another parentheses here. Yes, I needed another parentheses. Okay, so now we can see by the gender, female, we have a mean of 247, and male, we have a mean of 251.19. So this is how you would use this group by function. We can do the same thing for several others. Group by for mean. We can do the same thing for several others. So we're going to copy this and just start pasting a bunch of stuff which we can do for statistics. So this one I'll call standard deviation. And let me copy and paste this a few times. So we have standard deviation. We also have, let's say we want to do the median. Let's say we also want to do the minimum. And finally, let's do the maximum. So just basic statistics in this case. Obviously, this mean is going to change, all right? So this is going to turn into STD. This one over here is going to turn into median. This one is going to turn into max, or sorry, min, because we're doing min. And this one is going to do max, because we're doing max. And if we print all of this, you can see, okay, well, the standard deviation is 334.77, which is different from these values over here, 302.29. The median is 148.41 and 154.94. Minimum 30.02 and 30.03 per gender. And the maximum is, well, as you can see over there. So now this is the statistics that we can use in this case. You with me on this so far?
Yeah, just a slight question. So the category you're grouping by has a different parenthesis from the sales total, right?
Yes.
Okay.
And this is a categorical variable. When you use group by, you want to do it by categorical variables.
Oh, okay. Thank you.
Because by logic, if you're grouping by something, you need to group it by categorical variables. Why? Because you could only group by categories. Grouping by a bunch of numbers, you're going to get just random stuff. Rather than that, if you have a bunch of numbers, then you would probably want to explore the correlation instead. So now we can do multiple variables in this as well. So here, let's do this instead. Let's do, let's print this entire thing out. Let's change this to mean. All right, let's keep this as mean as is. But let us also do num underscore off underscore orders inside of here. So now we can see we do have a depreciated package, but it still works. appreciate it. Use a list instead. Not entirely sure what Python wants me to do over here, but generally speaking, it still works. You can see that, well, it produces the number of orders in this case, right? And we can also write it differently by doing this. Let's say mean per gender is equal to round, open parentheses, y underscore SLS dot. Remember we had the dot over here. We can also do group by gender, right? And then we had the square brackets, in which case we had, wait, I think I know why this didn't work properly. Yep, I actually need to put 2 square brackets inside of it. So I do 2 square brackets, and because I had 2 variables in there, sales underscore total and num of orders. And then after that, I do mean, open and close parentheses, and I can do a 2. All right. Now, if I do this, it'll run as is. But let's say we have a lot of variables inside of here we need to split up. Then all I can do is I can just do this, put a slash here. Then after this, I can put another slash. Then after this dot, I can put another slash, actually. Forward slash, that is, and then just go down. So this way, what I'm doing is I'm just segregating the code into various lines so that I do not have any problems in so that I do not have any problems in the code itself. And then finally, I can just print MPG. And here it's going to do the exact same thing that I wanted it to do for me. So this is actually a much better way of doing this type of this is actually a much better way of doing this type of thing. If it is that I kind of want to write like multiple variables inside of here, because this way I can put all the variables without it becoming too messy or one just gigantic line of code. Are you all with me on this so far? Okay. The next thing I want to do, and then this will be the last set of things that I want to do, is just a few more changing of data, is how to drop columns. All right. So if I want to, I can create a duplicate of the original file so as to not change the original file. So let me do YSLS is equal to Y underscore SLS. So here you can see I can do a print Y underscore SLS, and I can also do a print Y SLS. All right. So that's just basically me just producing multiple of these. And the reason why I want to do that is because I want to drop a column here. So for YSLS, the one that I just created, I want to drop maybe, let's say, the customer ID. So I can do YSLS dot drop, open parentheses, and inside of here, cost underscore ID. And then I will have to define access is equal to 1, where the access will drop columns. So now I can print the original Y underscore SLS, put a print function over here, and now I can print the Y SLS. And now you would see that there's a difference between the two of these. In one I had the customer ID, in one I did not have the customer ID because I used the drop function. Another very useful tool that you would need when it comes to data analytics. Because you will have to drop multiple columns when you are doing data analytics. Now let's look at renaming a column. So if I want to rename a column, ysls is equal to ysls dot rename, and let's say columns. No matter how many columns you have, you will just use columns, if I remember that correctly. Num, let's say I wanted to rename the number of orders. Let's say I wanted to rename that into something else. I'll just do orders. See, it's just like when I create a dictionary, in a sense. I just put this colon, and I just put the new name that I want inside of there. And similarly, if I wanted to do the same thing with sales total, and I wanted to just do sales instead, I can just do sales, right? So now let's print ysls, and here,
In the spelling of the YSLS dot rename.
sorry, what?
The dot rename, before dot rename, the spelling, is it correct?
Oh, that's why. Thank you. So now if you look at it, it's just telling me sales, orders, gender. Remember, I had sales, total, number of orders, and gender before. Now it just renames it for me. You with me on this so far? Okay. So now, coming up to the very last thing I want to do tonight, which is changing data in rows. So I want to change data in the rows, right? So for this, let's say we wanted to change one value from one row. So let's do print ysls dot iloc. Let's do 0. All right, and we want all the columns. So if I do that, you would see it's just one row of data that we get here, right? Sales 800, orders 3, gender female, right? This is just one row of data that we had here, and we can see this over here. This 0, it was sales 800, orders 3, gender female. Now, what if I wanted to change this value? ysls dot iloc, and let's say I wanted to change this 0, 0. So what is that going to change? It's going to change this 0 happens to be this row, obviously, and the 0 variable happens to be sales. So if I want to do that, I can just do this, and I can now change it to, let's say, 499. Remember, it was 800 before, right? So now I can print ysls dot head. Let's do head 2, right? So now, if you look at it, let me actually do a print. If you look at it, well, I just changed the value. But anyways, let me change this from 499 to, see, I changed the value 499 already, and that's why I did it. Let me change it to 600. So if I do that, you can see the original value is 499, all right? And now you can see that I changed this value to 600, and you can see it's within the same exact table as is. So that's if we wanted to change a row of data. Now, what if we wanted to change these females and males into different values? What if we wanted to convert all the F to females? Convert all F to female and all M to male. We will need dataframe.lock in this situation, and it would basically be something like this. So we'll do ysls.lock, in which case we will have to do ysales, or ysls, sorry, gender, and we have to do equal to F. Right? So this is us trying to locate the column that we want. We're locating the column, gender. And then we want to do gender again. So we're just calling upon the column once more, and we're basically saying we'll change this to female. Likewise, ysls.lock, ysls, and we're going to look for gender once more, equal to male, comma, gender, So, all right, let's look at this. Why are we doing this? This over here is a condition, and this over here is the column itself. So let me put this. This is how it is that it should usually work, right? We have the data frame dot lock, open square brackets, then we have the row, right? And then we have the column. That's how we usually do a lock. But to make changes, we need to use a condition. And all we're doing is that we're substituting the row for the condition. Why? Because we're looking through the rows. We're looking through the rows in a particular column through the rows to see whether or not this particular value in the row is equal to the condition we're looking for. So that's why we have here YSLS gender. We're looking through the gender column, and for each row in the gender column, if it is an F, we're going to change it to female. Likewise, for each row, if the value for gender is M, we're going to change it into male. So now we can print YSLS.head, let's say maybe 10. Do another print over here, and then let's also do print YSLS gender. All right, this is just for the column itself, .d types. So here you can see that it's changed the entire name for us, and it's still retained being an object. Okay, you're with me on this so far? Any questions on this entire thing that we did so far?